We are studying motion in one dimension. Let us see representation of displacement. So the displacement, it is a vector quantity, right? It's vector, and it is represented by a straight line with an arrow. Displacement being a vector, okay, you will see 2 points of the straight line there, PQ, and we also have learned that how vector quantities are symbolized with PQ and an arrow on top, right? So here the vector PQ represents 30-meter displacement. The vector PQ represents 30-meter displacement. In which direction? Eastward, right? In east direction. So I hope you can understand this, that the vector PQ represents 30-meter displacement in east direction. And there is a scale where 1 centimeter here is equal to 10 meter. Okay, you will see that there are 3 divisions here equally divided, and each division is 1 centimeter, which is equal to 10 meters. Right? I hope you understand this. Over here, origin P is what? It is the initial position. Okay, origin P is the initial position, and terminus Q, the ending, the terminus Q is the final position of the body. Okay, I hope you can understand this. I hope you are understanding this. Terminus Q is the final position of the body. And you also have to remember that the tips of the arrow on the straight line that you see here on the screen, tip of the arrow on the straight line represents direction of displacement. And which side is the displacement in this example? Eastward, right? Towards the east. And you also have to know and understand that the length of the straight line on proper scale represents its magnitude. I'll repeat this again. Length of the straight line on proper scale represents its magnitude. Like in this case, it is 1 centimeter is equal to 10 meter. So 3 centimeters would equal to 30 meter. That is the magnitude. Let us understand, or let us know more about the difference or distinction between distance and displacement. Let us see the first distinction. The magnitude of displacement is either equal to or less than the distance. The magnitude of displacement is either equal to or less than the distance. Okay, if you have understood what's a displacement and distance, you can understand this statement too. Let's see an example here. Okay, and this will be our first example. I'll show you 2 examples. Let us once again draw the initial and the final point. Okay, and I would just like to draw for you a straight path from A to B and a curved path, right, from A to B. So the body moves from A to B along a curved path, right? Let's see the first point. The body moves from A to B along a curved path, and the distance traveled by the body is equal to the length of the curved path, right? I hope you're understanding this. The distance traveled by the body is equal to the length of the curved path AB. That was distance. But the displacement of the body is along the straight line AB, the shortest, right? The shortest point from A to B. That's what displacement is, right? The displacement of the body is along the straight line AB. So by this we understand that magnitude of displacement is either equal to or less than the distance, and in this case the magnitude of displacement is less than the distance. And so obviously the magnitude of displacement is less than the distance. I hope you have understood this. Let's see the second example. Okay, suppose a boy is walking on a straight path. Okay, a boy is walking on a straight path, and let's say the boy has to travel 4 kilometers. Okay, let us mark the initial point as O. So the boy travels 4 kilometers towards east. Right, you can also see the compass on the right hand side where I have mentioned the east, west, north, south direction. A boy travels 4 kilometers towards east and then 3 kilometers towards north. Right, like you can see on the screen, the boy is traveling 4 kilometers eastward and he decides to change his direction, and then he's traveling 3 kilometers towards north. Right, I hope you understood this. Right, the boy is traveling 4 kilometers eastwards, and then from A he changes his direction and moves 3 kilometers northwards. So the total distance traveled by the boy here is how much? OA, right, that's 4 kilometers plus AB, that would be 3 kilometers. So OA, we'll just put up the values there to find out the total distance traveled by the boy. Right, OA is 4 kilometers and AB is 3 kilometers. So 4 plus 3 would be 7 kilometers. So the total distance traveled by the boy is 7 kilometers. Let's see the displacement. But the displacement of the boy will not be 7 kilometers. Right, that will be the shortest covered distance, right, from O till B. Okay, this is the displacement. So the displacement of the boy is O to B, right, initial point to B, that is 5 kilometers. Now this 5 kilometers is calculated by Pythagoras theorem. You'll be learning in maths, okay, or you have already learned in maths. So the displacement of the boy is 5 kilometers. Now in the direction, right, we know that displacement is a vector, so we'll represent it as OB with an arrow sign on top. So in the direction OB, that is the angle O, which will be 36.9 degree. You have learned this in math, so I will not be explaining to you about how we got 36.9 degree and 5 kilometers. Right, you have already learned about this in maths. So in the direction OB, that is 36.9 degree due north, right, due north from east, due north upwards from east in the direction OB. I hope you understand this. And so the magnitude of displacement is represented by the length of the straight line between the final and the initial position. Here the final is B and initial position is O. And so the magnitude of displacement in this example is 5 kilometers. Okay, that's what displacement is. Let's see the second distinction between distance and displacement. Let's see the second distinction between distance and displacement. The distance is the length of path traveled by the body, so it is always positive. Okay, remember that the distance is always positive, but displacement is the shortest path, right, is the shortest length in direction from initial position to the final position. So it can be either positive or negative depending on the direction it is traveling, right? Depending on the direction it is moving. So the distance is the length of the path traveled by the body, so it is always positive, but displacement can be either positive or negative. Let us see the third point. The displacement can be zero even if the distance is not zero. Okay, the displacement can be zero even if the distance is not zero. For example, okay, let's see one example. Let's say when a body is thrown vertically upwards, okay, if any object is thrown vertically upwards from a point, that is initial point, and let us mark that point as A on the ground, okay, then the displacement of the body will be zero, but the distance traveled by the body is not zero. Why? Right? You see that the body is falling downwards. The displacement here in this case is zero, but the distance traveled by the body is not zero. It is 2h. H refers to height. If h is the maximum height attained by the body, right? You see that point A is where it started and point A is where it ended. So initial and finish point is the same. So displacement is zero, but distance will not be zero. Let's see another example. Suppose a body is moving in a circular path from its initial point, and after some time you know that it will reach its original position after one round, like you see on the screen. A body moving in a circular path, when, like you see in this illustration, when reaches its original position after one round, then the displacement at the end of one round is zero, because it has come back to the same place from where it started, so displacement will be zero. But what about distance? Distance traveled by it is equal to the circumference of the circular path. Circumference of the circular path, and in maths you know how to find the circumference of the circular path, right? The formula is 2 pi r, if r is the radius of the circular path. So now I hope you understand that displacement can be zero even if the distance is not zero. So I gave you two examples. One is a vertical fall of an object and a circular movement of an object. Now here is the distinction between distance and displacement in summary. I want you to go through it by yourself, learn it, write down the note, okay, and keep learning it. I hope you have understood this.